Hello, everybody. Good morning, good evening, good afternoon, and thank you for joining Discovering Neo4j AuraDB Free with Michael and Alexander. Hi, Michael.
Hello, Alex. Hello, everyone.
Hi.
Hope you had a nice weekend, everyone, and it's great to be back. So we had a really long weekend, 4
We
days.
had a really long weekend, yeah.
Which was really good. And so, how was your time off, Alex? What did you
It
do?
was good. It was relatively relaxed. I took the time to get a few things done, household chores and all that good stuff, and I didn't go around. I was meeting friends on Friday, and then we went through the city. There was too many people, and we decided it's.
I can imagine.
Let's go somewhere else.
Yeah,
It was
I can imagine.
because of Thursday being a public holiday here in Germany. I think lots of people came to the city as tourists on the Friday, and it was super crowded. And so it's
I can imagine.
That's not,
so you need to go into some in the countryside instead, right?
Exactly. Yeah. But it was good. It was nice, very relaxed. Yeah.
Cool.
How was yours?
Yeah, I had a good time too. So what did I do? So I went cycling along the river, which is usually quite nice. I went swimming for the first time outside this year, and
is it warm
but
enough
it was
for
really
that?
cold. It was nice, but it was really cold.
Did you wear a wetsuit?
No, I just was just bathing pants, and then so that was it was a bit
Longer
cold.
than 30 seconds?
Yeah, so I went to swim like perhaps 10 minutes or so, but
okay,
not much
wow.
longer. So that was good. Then I went to visit some friends as well. I watched Farscape, the first episode with my daughter, but she was not so impressed. I mean, I find it one of the best science fiction series there is. But she said, Dad, you and your old series.
It didn't age well, I guess. Yeah.
No. But it's so good.
I watched The Fifth Element yesterday on
nice.
Blu-ray.
That's also amazing. Yeah, I love The Fifth Element as well. So that's
nice.
But I guess it's also counts as like one of the old. It's so funny and so well done. It's kind of one of these timeless movies that you can watch.
It's a little it holds up it holds up quite well, I think. It's a little weird, but it's still watchable, unlike some other movies from that period.
Yeah, and I started to read the third part of a science fiction novel trilogy, which I really like. What's it actually called? It's about Adrian. Let's see. For the Final Architecture, the series, and it's really, really good. It's about, there's some ginormous beings that's like moon size, and that basically turn planets with lots of people on them into space art, basically, and killing all the people. And so it's kind of humanity fighting and figuring out how to deal with this, and it's really well done. Lots of different alien species as well, and lots of interactions. and
okay.
I was actually waiting for the third part, and it came out in early May, late April or so. So I was really I see, yeah,
just a couple of weeks ago.
It's just came out, and so I've been reading, so I'm 35% in or so, and everything is very open, but it's really, really nice. So I can definitely recommend it for those of you that like science fiction. It's a good one as such. Yeah, so and I donated blood, so if you
okay, cool.
If you can, please donate blood as well. So that is something that I definitely recommend to everyone who can do it. It's really important to save other people.
Very important, yeah.
So yeah, so that was my weekend. So
cool. Before we dive in, this is now will be now regular session. Speaking about notes, so call for paper is open. Let me put the link in chat. Where do I have the link? Here it is. We're looking for your. Here we go. We're looking for your contributions. So if you have a topic, anything goes. talking about graph, particularly about in the topics of visualization, software development, applications, intelligent software applications, and AI, machine learning, data science field, then submit. But if there's anything else you have, a graph itch, and you want to talk about this, then obviously also welcome. Call for paper ends in June, end of June, so you have another month. So it's enough time, I think, to send something in. And yeah, it would be great to hear from you, to have see your talks. And the sooner you send it in, the more likely you will become prominently featured on the Node23 website.
Exactly, because we want to pre-select
early.
number of early submitters, right? So that's really good. And to remind people, it's an online conference, right? So you can give the presentation from your living room. It's live, so we don't pre-record or something like that. So it's live, but you can do it from wherever, and it's 24 hours all around the world. So no matter what continent you're in, where you live, you can always we can always find a slot for you. So don't need to be afraid. And we have full-length talks and lightning talks. So if you kind of just have one, interesting library or one topic that you want to talk about, then also submit a lightning talk. Those are usually quite good because they kind of focus on one topic and don't meander for too long, but it's very focused. You get some good information out of it, and then it's also not so much effort to prepare for those. So lots of good opportunities there.
Yeah. So that would be nice to see many submissions. So you so we have a fun event. And looking forward to that. It's happening in October. So as well, you've got some time between submission now and final presentation. So you can obviously you don't have to do anything right now. But
exactly, you don't have to have it ready.
Exactly.
Right?
Yeah, so that's what I mean.
It's good enough to have the idea or the abstract, and then that's then conference-driven development, as we call it. Right? So in the
deadline
DevRel speaker circle, it's kind of conference-driven development. So if you have an idea for something that you want to build, but you're not sure, then submit an abstract somewhere. So you have an external deadline, basically, to actually build the thing as such, right? And that's sometimes, that's what you need as such. Right.
Absolutely.
Hey, John, Alisera, Ashwa, good to see you.
Good to see you. Hi, everybody. And we are diving in. I'll briefly talk about this. I think we did this now for so many times, but still, it's the regular
There's
show.
Still new people watching it,
but still new people watching, exactly, and it's always good to recap a little bit. So and maybe also to iterate again, if you have a data set, if you see something, if you have something you want to share publicly, you have either you've seen publicly somewhere available, or your data set is you publish it yourself via whatever means you have, and you would like us to have a look at it, then you can share it with us, and we can explore it at some point.
Oh, and by the way, if you like the sessions, please also share them with people that might not have seen them. So because we record them all, and so it's really good for newbies that get started with Neo4j or want to know why to use a graph database, what it's good for, and so on. So while you might know all these kind of things, if you share this with other folks that might not know what a graph database is good for or what you can do with Neo4j, please share them widely so that others can also learn and benefit from it as well.
Yeah, and the goal with this series is basically that we find as many different data sets as possible and play with them, and so to show how widely usable a graph database is and how many applications there are that can benefit from the addition of a graph database. So we talked about genealogy, we talked about recently fire, we talked about the London Underground, we talk about all kinds of different data sets.
Hotel reviews, Kickstarter, and lots of different things.
On superheroes recently. So it's all kinds of things.
Song contests.
And it tells you that there's lots of applications and versatility. So yeah, we generally do. We look at a data set, then we develop a model to think what kind of how the graph should look like, what kind of question would we ask, and that model derives from there, and then we do loading and querying in Aura. And AuraDB free is the free edition of Neo4j graph database as a service offering. So you get an enterprise edition for free with some limitations of 200,000 nodes and 400,000 relationships. So that's plenty for any small project. I think we in all these episodes we did, we ran in a handful, maybe 2-3 or so. We ran in the limitations because the data set was just too big. But then we always were able to cut it down and then use just a portion of it, and then that's good enough. You get the new workspace experience, which includes a browser, Bloom, and the data importer in one tab, so you don't have to switch about. It's free forever, so that's the big difference from previously. You might have seen a Neo4j sandbox, which closes down after a couple of days. This stays with you as long as you like it and as long as you use it. Yeah, get there. I'll post a link as well in chat. If you don't have a instance already for you, then you can get it there. And yeah, today we talk about software dependencies with deps.dev, which I must admit I don't know what that is.
Yeah, exactly. Actually, it's something really interesting, which has so it's a website and an API and a database basically, which has been released a while ago by Google. So actually, I wanted to do this for some time. So I did. When did I publish this? Like a year ago, roughly, like June 2021, right? Oh no, that's actually 2 years ago. So I've been wanting to do this for some time, but we just never got around to do it. But it's really nice because it basically is an combined package dependency database. So no matter if you're using JavaScript or Python or Java or Go or .NET. So they kind of captured a lot of the packages from these systems, and then you can kind of find them, you can kind of analyze them, you can visualize them, you can see the dependencies. There's also security vulnerabilities listed and so on. So it's basically an open source service from Google, so that you can better understand like how software dependencies work, what vulnerabilities are there, and how it works. So for instance, if you look for Neo4j, we can say Neo4j kernel, and then it says this is a newly released version. Please check 5.5 for all the details. And so you see one security thing that has been fixed already. You see dependencies, you see licenses, and dependents as well. So you can basically also see, so you see it also here on top, dependencies and dependents. So for instance, you can see all the dependencies that Neo4j kernel has in terms of like Java dependencies. So you see all the Neo4j stuff, but you see also Eclipse collections, JC tools, there's bcrypt somewhere, there is Lucene, I think, somewhere, and so on. And you can visualize it as a table, but also as a graph, which is kind of cool, right?
Nice.
So they also have a graph visualization, which we probably want to reproduce, right, as such. So this is just these three, I think, or something. Visualizing this table, and this is only this one package, right? So, but what happens if you want to do more than one package? And it also has dependents, so that means which other tools are dependent of in library, right? So for Neo4j kernel, it's mostly the Neo4j dependencies, but for another project, let's go back and say we search for TensorFlow or something like that, right? TensorFlow package. Lots of security things, number of licenses, and then you see it depends on 22 direct and 20 plus 20 indirect, so 42 packages, but 2,100 packages use TensorFlow somehow, right? Either directly or indirectly, right? And then if you look at this, then you can basically, oh, they don't even show you this as a graph. So you can see this as a graph, but not this as a graph. So that would be interesting to see kind of who's depending on TensorFlow also as a graph. And what I wanted to do is actually to see, can we pick like TensorFlow, PyTorch, and Keras, and some of these JAX and so on, some of these machine learning libraries, and see what kind of overlap is there between dependencies and dependence between machine learning libraries, right? So that's what I wanted to do.
Yeah.
And
what's also what could
Hmm?
also be interesting in this case is, like, when you look at the vulnerabilities. So I had in the Neo4j live sessions a couple of weeks ago, I had guests who were talking about the software dependencies and vulnerabilities that could happen in your company. And if you look at this, you see here you have the software, the vulnerabilities listed as well. So if you think about it, you use a software or you use a product that has maybe no vulnerabilities, but it's depending on, let's say, different tools indirectly, and then via these vulnerabilities you get basically vulnerabilities in your stack introduced.
Exactly. That's the biggest concern, right? So your direct dependencies might be okay, but the indirect dependencies might be not even that they have vulnerabilities per se, but they might depend on an older version where the vulnerability is not fixed yet, right? So, and then do you need to basically manually pull up the version of the dependency, of the indirect dependency, to basically get rid of the vulnerability. But then what could happen is, of course, if you have between, for instance, if it's not a minor version but a major version, then perhaps the API changed and you can't use it. So you need to update also your direct dependency and so on. So it could be like a cascading chain of changes that needs to happen from there, right? And so that's kind of the idea, right? And you might have spotted here at the beginning, they announced an API here. So back then when I looked at it, it didn't have the API, but now it has an API, so that's good. But I saw also that the API is not complete. So for instance, it does not have the dependence. So if you go back to where we said who's depending on TensorFlow, this information is actually not in the API because probably there's so much data in here. But we can steal it from the UI, and we look into that later on as well. So
we borrow.
Exactly. We just scrape it from the UI. Exactly. But if you look at the API, by the way, while we're doing this, we should probably spin up our Neo4j instance. So I just go to Neo4j Aura, log in, and then I can create my free empty instance here. So I just click on create, and it gives me credentials that I can also copy here and download it. It's important that you download them because then you have them.
Download, otherwise your password is
exactly.
not,
so and it calls it initially instance 01, but we can just rename this to dependencies, or dependencies, right? Dependencies. Okay. So, and it takes a few seconds or 2 minutes so to spin it up. And while it's doing this, we can look at the APIs a little bit, right? So APIs, so the APIs, I'll make it a little bit bigger. Basically, it's a REST API, pretty straightforward. You don't need to log in for it. It's just a public API, which makes it even easier for us as well. And there are some conventions for package names. So they do URL encoding of all the special characters like dots and slashes and things like that in the package names. Something to know. And then some of the packages, as we saw, are not immediately updated, but it takes a bit for them to update them. But in general, there's like a number of simple API calls, right? So for instance, here is one that's called get package, and it gives you information for one package, right? So if I open this for the npm package colors, we can basically see this is the colors package. It's from npm. It's version 1.40 and 1.50 as two versions, and that's basically it, right? And if we change the package, we could say, for instance, Neo4j, the Neo4j driver, right? So then we see basically it's an npm package for Neo4j, and it has all these versions, as you can see. And actually, that's not the Neo4j driver. That's the Neo4j, the original Neo4j connector. It's called Neo4j driver. So we see here Neo4j driver, and it goes all the way down to version 5.8.0, which is the current version, right? So it has lots of, so how many versions does it have? 263 versions, right? So that's a lot of versions. So that's
from
kind of
002.
from 002, right? So and
Yeah.
then 10, and then it went from there, right? And it had a jump in between from 1.7 to 5.x. So here's 1.7, and then the next one somewhere should be then basically according to the Neo4j database instance 3, 4, and so on, right? So there was a jump between those. So where then went closer to the Neo4j instances. Okay, that's kind of just a package information, which is okay, but it's not so interesting, right? So it's basically just a package and their versions. We can pull this in, but it's not so. So we would probably model this as an as one node for the package and then version nodes around it as such, right? The next one is you can get one specific version, then you get basically one information for one specific version. So that's a little bit more interesting. Gets us the license as well, and gets us the additional information like links to issue trackers, source repositories, and homepages. There's no advisories here for colors, but if we change this to, let's say, PyPy and TensorFlow. So, and then I need to figure out which version it is. Oh, 1.5 works as well. So you see basically here's no license for TensorFlow, but you have all these security issues that we talked about, right? And no links as well. So it depends on the packaging system, how well they pass out the links and the information, right? So, I mean, PyPy has all this information, they just don't pass it out well enough as such. So that's another one that we can look at. What I'm mostly interested in is the dependencies, right? So which is basically our graph thing, right? So, and if you look here, for instance, at React, what are the dependencies for React? It's basically JS tokens, loose env, and that's it. That's not a lot of dependencies, right? So perhaps the package or pull all the other things in. And you also see what's kind of interesting here, that they already have this kind of graph information in here, right? So they basically have, say, from node 0, which is probably the dependency, to node 1, which is, sorry, from node 0 to node 2, and node 2 is basically the React itself, right? And then you have, also that's not correct, right? So from React to JS tokens and then loose env, it's a little bit weird, right? So, but this is kind of the relationships in the graph. So we should probably look at the data here. So if you pick npm React and look at dependencies, it has only 2 dependencies, right? And you see that, oh yeah, it's true. So it shows the indirect dependencies as well, right? So you see, that's actually interesting. So here you see React, it depends on loose env, which is an environment package probably, like pulling an environment like .env. And then that depends on JS tokens, right? So you actually see indirect dependencies as well. So if you look at the TensorFlow here from PyPy, and look at dependencies as a graph. Or here you also see, so they're like direct dependencies like these, right? And then indirect dependencies that are going 2 steps out. So that's actually something that we can pull in pretty quickly, right? So, and to start with, I would say we'll pick an simple one that should pull in the package itself with a bunch of additional information. So we could probably get just the get package here, right, for a number of packages, and then look at, so this has versions. So we don't need all the versions. What do we do? Or should we go directly for the graph and then look at the dependents? I think we can go directly for the graph, because then we can also get some information about the other packages as well. So we can do recursive queries as well. Right? So if you look at this, the data that we get here is kind of the nodes and the relationships for each package, right? So we can fetch for each node the information, system, name, version, and for us, kind of the name would go into the package itself, and then we would create a version node that the other ones are dependent on as well, right? And then continue from. Or we can actually put a version on the relationship. Perhaps that's easy enough for us for this purpose, as such, right? Because they also have the dependent requirement and then the actual dependency here, right? So there's basically everything up to 1.2 and sorry, everything up to 1 or to 2, and here's 1.4 basically. So that's kind of this semantic token here, and here's 3 or 4, and this is kind of 4 as such. So okay, let's try this out. So our database should be running now. We can open our connection, and I'll just open my credentials files that I downloaded and copy the password in here. Connect. And now, so we don't have a CSV file, so we could turn the JSON into a CSV with JQ, but for the time being, we'll just write the code directly in Java as such, right? So that's probably an exercise that we could do later for one of the other ones that we can show as well. But if you pick this one, or let's pick, let's see if we go to, I mean, Neo4j is not so interesting because there's lots of internal dependencies as such. So it's probably more interesting to look at something like here, the TensorFlow version is 2.12.0. And so we would basically say, here's our API call. Yeah. So we would say instead of npm, we have PyPy. PyPy packages TensorFlow, and then versions is, what did I say, 2.1.0? What's this one?
2.12 something?
2.12.0.
Yeah.
2.12. Right. So here we have like all the nodes for the different Python packages, and then we can find the relationships further down. Right. So I just copy this URL as such, and then we'll try to load this into Neo4j. Right. So we can close this. So loading it into Neo4j, we can actually do with APOC. APOC is an utility library for Neo4j. We can call APOC load JSON, just pass in the URL here, and then we can actually yield value as response, and then it basically does the URL API call and gets the information back. Right. So we see here exactly what we've had in the response here. Nodes and relationships, and first we look at nodes as such, right? So a nodes is an array, so basically we can return r.nodes, which gives us the whole array as such. So we see here the array of all the nodes, but what we actually want to do, we want to have each node individually, right? So that's actually a good question, right? So because if you remember, in this API response, the edges have not IDs or package names or something like that, but they have like an index into the nodes array, right? So which you kind of need to preserve to connect the information, right? But there's this index is not available here in the nodes area, right? So it's basically just the index in the array. So it's something that we need to keep and mustn't lose as such. So if I just turn this nodes area into elements, which I can do with unwind, I can do unwind r.nodes as package or something like that, right? Return package. Then I get like all the packages individually as rows. Such, so it's 43 results. But I don't have this index anymore, right? So it's kind of lost a little bit. So there's a trick that we can do is basically we can actually say unwind range of r.nodes from 0 to size r.nodes minus 1. So it's basically just create an index into this array, right? So and that's in range from we need just this from 0 to size minus 1. So if I just return this, then I get something from 0 to 42. Right. So 0 all the way to 42.
Okay.
And then we can actually return index and r.nodes from index as package. We have preserved basically this numeric index as such, so we can use it actually to add it to the node to connect it again, right? So, and that's what we're going to do now, right? So, so we just say with index and r.nodes from index is package. We just create a package node, key package, and let's say we use we do PyPy as a system as well, as an additional label, or we can actually set this also later. So we merge a package on the let's do this here. PyPy on the name, which is package dot version key dot name. So if you look at here's package, here's then version key as a sub entry, and in here we have name as such, right? And what's also interesting, they also added here like the relation direct or indirect as such, which they use to group things, and so you can basically say we have so many direct and so many indirect packages as such, but you don't need this information actually.
The overview, yeah.
Exactly, for the overview, exactly. So, so we got PyPy, we got our name as such, and we can probably say on create set p.version equals package version key version. So this should give us the version, and we also set p.index is IDX, right? So that's kind of just our temporary thing that we need to connect nodes as such, right? Cool. And if you run this, this should give us like the 43 nodes for the different packages here, right? And if I click on this, then we see basically, let's zoom in a little bit. You see like all the different packages that we have here. Currently, they don't have relationships. You can make them a little bit bigger as such. But we see that they have we have the index, the name, and the version here as such, right? Cool. And that's step number one. And in the second step, we would look at the edges as such, right? So we can basically use the same query as such here. And we, instead of returning r.nodes, we do r.edges. And r.edges is basically this array which has a from node, a to node, and a requirement, which we can put on the relationship as such, right? So that means, but here we don't need any special things, so we can just do an unwind on the edges. Unwind r.edges as edge. Then if I do return edge, it would return me 57 results as such. And now we can basically find out two nodes and connect them and create this data as such. So if I now do, we match our from node as package PyPy with index is edge.from node here, right? This one. That's our source. Our tour is tour node, right? And then the requirement we set as a relationship. What's interesting is these indexes are not relevant for the larger graph because they're only relevant in this short time while we're creating the data, right? It's not really that we need it later. So from that perspective, we can also remove them again, right? So because if I import the next package, then there's another package with index 0, right? So we actually don't want to keep them around to not have accidental things as such, right? So what we can do is now we can actually delete, remove from.index and remove to index. So then we get rid of the two fields as such. We can also do this at the end. And then the other thing that we wanted to do is create a relationship from depends on to, right? Rel, and then we say here on create set rel dot requirement is kind of this semantic version requirement, and we say edge requirement. Right. So we basically copy this information over from the source to the target node, right? And then we remove the two indexes. And if you haven't done anything wrong, this should actually now go ahead and create our nodes here and the relationships. Sorry, the relationships, right? And if we now look at this depends on relationship, we see these direct and indirect relationships. So this limits it to 25. We can actually remove the limit. Yeah. We pick a nicer color, something like green or so. Right, so you see actually now, or if we make the packages that now smaller actually, like this, then you see here's TensorFlow, right? So the core package. And if you squint a little bit, then you see that it's exactly the same graph as we have here, right? So you have TensorFlow up here, you have this little cluster with requests here, Google OAuth, and Markdown and so on, right? So it's basically, you can see that we got the same. Here's Google OAuth, here's Markdown, here's requests, right? And so that's actually quite nice, right? So we can now, if we want to, we can also combine this into one statement so that we can load it at once. For instance, by doing a subquery for each of the parts as such, right? Exactly. So there's also a trick where you don't actually need to store the index in a graph, but you can keep it around temporarily and turn it into a lookup map and so on. But that goes a little bit too far for the intro session. But if you ever want to know how to do this for real, so there's an Epoch video that I did a while ago, which actually puts each created node into like a lookup cache where you can look them up by index, and then you don't actually need to put them into, or actually into an array, and then we can fetch them from the array as well. So that also works as such. Right. Okay. Also, actually, it's not so hard. So should we do it? So then it becomes more
up to you. I think, yeah. I mean, you mean combining it into one, or?
Yeah, exactly. What we would do instead here is instead of doing the node index here, we would just do an unwind of r.nodes as package. Unwind of r.nodes as package. we merge our node in here, and then we just collect. And we can actually do it as a subquery, so that it doesn't pollute with R. This is our subquery, and within the subquery we can do the unwind. We do our created nodes, and then we return collect P as packages. So we then have an array of packages where the index of the package is actually the index of in the array, right? So because we create the nodes as they come along, so we can actually use them the same way. So we collect them in the same order, and so the index
I see.
is actually
Okay, makes sense.
index, right?
Yeah.
And then we just take the second part here and put this also into an. We don't actually need to create index anymore. And here we also do a subquery with R for the relationships, and we unwind the edges. And instead of matching these nodes, we can actually take them from the packages with packages of edge from node as from. That's kind of our source from this array that we just created. And then
of course.
we do it like this as to node. We don't need this match, and then we basically do the merge here. Return count star as rels, and then we just return size of packages as num packages and num rels. So we basically return how many packages were created and how many relationships
nice.
were.
Yeah.
Right, so this is actually a nice one. So, and if you run this again, it should actually not create additional information because the nodes are already there with these names, and the relationships are also already there.
Did we create an index on the names?
We didn't, but we could do this. Create. Let's do a constraint
rather. Yeah.
On package PyPy assert. So because we can have the same name in different package systems. So for instance, something like there's a TensorFlow package for NPM as well, and I want to assert that in this PyPy there's a unique name for a package. For require p.name is unique, right? And I on it constraints if not exists, and then exists, and then here is on instead of for, and then it creates the constraint or create. Oh no, what's wrong? I always get the syntax wrong. Oh no, we're there. Okay, it's the on needs to go behind the name, and this is for basically instead of. So and now we should have our statement here, which is really nice. And actually what we can do is we can even do pull this out. We can say basically as with PyPy as system. I don't know if you want to call it system, TensorFlow as name, and 2.12.0 as version, right?
Yeah.
We can pull this out.
You can create variables. Yeah, that's good.
Exactly, and then we can say here, this is system. This is name, and this is version. Right.
A plus after the name.
Yeah, thank you. So we can actually even put it like this, so it's easier to read. And so that means you only need to change the first line to make it reusable for something else, right? So if I run this again, it doesn't like us because we have to pass in packages here as well. R.packages. R is our response from the query, and packages is our array that we just got here, and we need to pass it into the query. And it doesn't have edge here. Oh, and edge we need to write here as well. So, and it didn't create any additional data. Otherwise, it would have said that it created any data here. And it created 43 packages and 57 relationships, right?
Yeah. Now we could
and
change.
Now we can,
yeah.
Exactly. Now let's pick another package. Let's say we use PyTorch package. It's 102, right? So we see it has, it had no dependencies. Okay, then let's use Keras. Keras has also no dependencies. That's unfortunately scikit-learn. Do we have dependencies here? Okay, it has a bunch of dependencies as such. So we can, for instance, scikit-learn 122 as a new thing. Scikit-learn 2, right?
122, yeah.
And then it would create 5 packages, and so we now should see also the scikit-learn packages if we remove these as well. But the other thing that we can actually do now is with our nice statement that we have is we can actually go over the dependencies that we have in the graph already and get the second degrees as well, right? So we have now in our graph 47 packages, and we can fetch the dependencies for each of them as well, right? So which is actually quite nice. So what we can do here is just say match. Let's say source is our, or let's not call it source. What do we call it? I don't want to call it P.
You mean the start?
Yeah, it's like kind of the start package, right? Yeah, or initial.
Initial package, root package. I don't know.
Yeah, let's call it. Yeah, we can also call it root. So it's package PyPy, and instead of getting this information from as hard coded, we can just say we use PyPy as system, and instead of hard coding this, we actually say root.name is our name, and root.version is our version as such, right? And then we can basically go over them and import their dependencies as such, right? And to make sure that we don't import them time and again, we can also set an additional property on the root. For instance, either we set a label like imported or something like that, or we say root.imported. That's true, right? And then we say here where not root.imported. So it would set this imported once, and then doesn't pull them in the next run that we do, right? As such. Okay. So we need to pass in the root here. So, and then we need to have a set between and width between set and call. Well, actually, I can probably do it like this. Then we don't need root here, so it's easier. So, and it didn't do anything. Why didn't it do anything?
Because we haven't defined root packages. Or have we? We should have. We need to tell him what's our.
It should return all of them. No.
Should it? How would it? Would it get there?
That's actually a good question, because it's an. We can probably do this. Where it's not set, or where not equal true. But it's also weird, right? So because it's yeah. mean, it's the kind of the null logic that null returns false, basically. So we can just say where root imported is null, and then right, that's 47.
Yeah, we haven't.
Now I've closed the window. Fortunately, all the history is there. Where root imported is null, and then basically it goes ahead and imports for all the 47 packages the number of dependencies again, right? So that means now in our graph we should have more. We have, let's see, why is it still 47 relationships? That's interesting. 47 nodes.
Yeah,
that's weird. How many do we have where turn n where n dot imported is not now?
I think we added it to all the nodes now. They have
yeah,
all
but
the imported true.
So I wanted to say is now has known, so it didn't pull any additional nodes in. That's interesting. So were they already all in the set of dependencies? It seems so, right? Interesting. So perhaps we should
maybe try an
a different package. Yeah. Let's see. Matplotlib. Is this plot? No. Matplotlib. So Matplotlib has a bunch of dependencies. So
yeah, let's try to.
That's Matplotlib 371. Okay. Back to our statement. Yeah. Matplotlib. Was it 371?
Yeah.
But now imported 13. And if you do our fun statement again, let's see if it added more. No, it seems that the transitive ones are already always included, right? So it doesn't fetch additional ones for the dependencies themselves. Interesting.
I see. Okay.
Anyway, so we are almost out of time. What I wanted to look at is really quickly is the dependence, right? Because that's the interesting bit, is kind of how many libraries depend on our library, right? So Matplotlib has 15,000 direct, and then another 5,000 indirect dependencies, right?
Yeah.
And so they show only a subset, I think 100 or so here in the list. But what we can do is basically we can go to the network tab, and in the network tab there's an this one, I think, the 371. And I think this gives us dependence. This one should be dependence. So we can open this in a new tab, and we see this is our Matplotlib version, and then the total counts, directs and indirects, and then it gives us a sample as such. So like the 100, it's called direct sample, and this is a direct dependency outwards, right? So that another dependency depends on our version, right? So that's something that we can also pull in, where we see also kind of how is my library used, right? So which is often important from a package maintainer perspective. I want to see how many people are using my library as well, right?
Yeah.
So, and this should be also pretty straightforward because we have our, so this is not an official API. As you can see, it's kind of like an underscore s, so it's something that I use for their website. but it's still something that we can use, right? So we can do epoch load JSON, as in our dependence, yield value as response, return response, and this gives us the information. So direct count, that's our package that we have, and then indirect count, and then it gives us an indirect sample and direct sample, basically, right? And the indirect sample is not so helpful because it doesn't tell us which the indirect ones are depending on, right? So it gives us like which packages are there, but not.
I see. Yeah.
Right. So I think here you see the direct ones, and I'm not sure if you can relation indirect. So, but it means that like there are second degrees, but it doesn't show us what they depend on in a way, right? So which is kind of the a little bit of a challenge because then we can't import them, right? So it says here's direct sample, and I don't think it has edges from to.
Ah, shame.
Right. So we can basically just take the direct samples and use those directly, right? But that still gives us 100 of such, right? So we can basically do the following. Here we find our version name. So basically we say again with system matplot as name, and then 371 as version. This is our system. This is our name, and this is our version, right? And then we want to have the direct sample.
You need a plus after the version.
Yeah. This is our direct sample. And so what we want to do is basically we want to find our node or merge the node. So we have our root is basically py name, right? Even say version. We don't have it yet. Or we could actually say on create set root.version equals version. So it would be actually more correct to do the version check here in the merge, because then different versions can have different dependencies. But for the ease of like our visualization, I'll just do it this way. And then for each direct sample, we just do create a new node for our package here, right? So it's basically we create a new dependent, which is in PyPy package, has a name of r.unbind as steps, and it's call it deps dot or entry, and call it entry dot package dot name, and then here again on create set web dot version equals entry dot version. So the version is outside of the package, right? So you see like here's the package name and here's the version. So as I said, it would be more correct to have the version inside of the package, because if you have then multi-version setups, that would be more correct. But I don't want to have gaps because we don't have a version imported. And then basically we say our dependency depends on our root, right? So that's kind of because it's the dependence. So this time we put the direction from dependent to the root as such, right?
Of course, yeah.
So, and if we do this, and then we do between merge and call with star, and then it created 100 nodes because you said this sample has, also in total has 15,000 dependencies. It basically shows, so that means we have now many more packages, and now we can again run this here for our other versions. So for instance, we can say, okay, if you look at TensorFlow, what version of TensorFlow was it again? Do you remember? 2.12. 2.12.0. So we can basically go here again and say, this time we want to do TensorFlow 2.12.0. And it created another 100 packages and dependencies, right? Which is actually now also nice if we want to explore this data. We should be able to go over here to Bloom to explore, and actually let me
to refresh maybe.
Yeah, let's just recreate the perspective. Delete. Create generate perspective. So we probably want to add package here as well, and move PyPy. And then we just see packages. So these are like all the packages that we have, and then we can basically say reveal relationships, and this gives us an kind of hairball, right? Can expand more, but that's all the ones that we have. What we can do now is, which is kind of interesting, is we can do the hierarchical layout, right? So which is kind of better suited for this kind of dependency graph, because now we can basically say, give us like the hierarchy from a start node, and then kind of who depends on what, right? So this is kind of URL lib, and so we see URL lib is actually one central one, because lots of other things like requests depend on it, and then requests has a lot of other dependencies as well, right? So that's also interesting from that perspective. We can also say, if you only look at requests here as our root package, and then we say who else depends on requests, right? So that's kind of these two. So we have TensorFlow and that, and then we can go one level further and say who depends on these, and then we can go one level further and who depends on these, and so you can basically build up and then you have this massive, because all the libraries depending on TensorFlow basically, right? And here you also see that basically TensorFlow depends on TensorBoard, right? So which is kind of interesting, right? And so you can basically subsequently connect these things. The other thing that you can also do is imagine I just have these two packages on my screen, and I just want to know how are they connected as such. I can also click on give me the shortest path between these packages, and then it basically creates this shortest path between requests through TensorFlow to stlearn as well, right? So that's another interesting thing that we can do. And then basically you can do other explorations as well. And you can, if you had also imported the security vulnerabilities, we can add additional labels like vulnerable, and then it could be rendered red, for instance, or something like that, or other things as well, right? So there's more that we can do, but we are a little bit out of time. But this kind of gives you the basics to import either from PyPy or from NPN or from Maven or Cargo, basically this information from deps.dev, and then this gives us the information. So the security advisories is when you get the version. There's the API here again. In get version, this would give you the security advisories, right? So then if you wanted to import them, we can also go over our nodes in the graph and import additional information for all the packages that are in here, like do I have like homepage, issue tracker, source repo, or advisories as well? And so I can basically go over this data and build up my graph of dependencies as well. Right? And I'm not sure if they actually have all this data also available here. They actually have it in BigQuery as well. So you can basically get the data in BigQuery as well. The problem is it gets really expensive, right? So because BigQuery queries basically charge you on the data that you touch by querying the data. And so it would be nicer if they just provided a dump of the package of the data in total, right? So but I don't think that there's any dump available. So you need to basically go to BigQuery and query it directly. Okay, I think that's what I wanted to look at today. Are there any questions from anyone? Ashwa asks, if you have any data imported in this workflow, if you have created any relationships wrongly, then how can we find out the wrong relationship and how can we rectify it? So depending, good question, Asha. So either you can identify, it depends on how do you identify your relationships, right? So you can basically say, imagine we created a wrong relationship with a wrong type. We could just say, we find the relationship by wrong type. And then we can either delete the relationship as such and get rid of it. We could also say, okay, it's basically has a certain attribute, whatever, has version true, and that identifies our, for instance, if I have depends on and has version true or something like that, and I want to get rid of them, I can just delete them. Of course, I also can set attributes here and override them. I can also, with APOC, there are some refactoring procedure calls. APOC relationship create set. This let's see, we can just call APOC help because I don't remember all the names. And so we can, I think there's a redirect. Oh, so, oh, exactly, they're all under refactor. Refactor. So we can, where's it? We can change relationship directions. So we can basically put a new source or end node. We can invert relationship directions with APOC. So for instance, APOC inverts relationship direction. So if you did it in the wrong direction, you can turn the relationship into a node with extract node, which is also useful sometimes when you said, okay, this relationship, imagine we had like an inversion relationship or something like that, and then we want actually to turn this into an inversion node. Then you can say, okay, we want to turn these version relationships into version node. You can merge nodes together, and you can also rename a relationship type as well. So if you have a wrong relationship type, you can basically rename it to a new one, basically, as well. So that's some ways of how you can do this. And in the APOC docs, you should be able to see this under the refactor, graph refactoring.
Yeah.
Yes, I can't see it right now. Execution. Why can't I see this?
I think it's currently extended. I think it's in core.
Oh, graph updates. I think, is it updates? No. Oh, yeah, you're right. Sorry. Yeah. I actually thought
I put the link in chat already.
Oh, thank you, Alex. So graph refactoring here.
Yeah.
You have extract node from relationship, invert relationships, redirect relationships. So you have the docs for them here, and basically from and to can basically change relationships, and then they can point to something else as well. right? And with invert, you basically turn them back, and you can also change the relationship type from something to something else. Right. So you find the existing relationship, and then you set a new type. Super.
Change. Yeah, lots of options.
Super.
All right.
Good question.
Good question. Yeah, that's always important. You go somewhere with your data model, and then you realize, oh, maybe this relationship should have been called something else, or there is another relationship that's better now, or something. You don't have to.
Yeah.
You don't have to trash everything. You can work with it and adapt according to your change of the model.
Yep.
Yeah, I think that's we're at the end of this episode today. Thank you for watching. Thank you for your questions. And thank you, Michael, for the presentation. We will take a short break over the next 2 weeks, so we won't be back next Monday or the week after. I'll have Jason tomorrow. So we will talk about his mock graph data generator, which he developed. If you don't have access to a data set that's kind of like close to what you want to do, but you want to play with data in the graph and want something that is synthetical or analog to what you are using in your environment, then this can help set up something that is synthetic data, basically synthetic graph data. And we will look into this tomorrow. 23rd, exactly. And so if you're interested in that, tune in. Otherwise, looking forward
it's a really cool
seeing
tool.
you on. Yeah, I think so. Yeah, it's pretty cool. Look forward to seeing you either on the forums or on Discord or somewhere else. And obviously, again, submit your talks to Notes. With that, have a good rest of the week. Any final words, Michael?
No, have a good time in between and share the sessions with other folks as well.
Exactly.
So that would be really welcome. Cool.
All
Thank
right.
you, Alex. Thank you, everyone.
Take care. Bye.